I'm David, and I want to tell you today something about testing in IoT. In general, this is my second trip to Ukraine. The first one was on my bachelor's party, and I don't remember clearly everything. But after 2 days, I can say yeah, the city is quite beautiful. So that was my private opinion, and now I want to give you some information, some feedback about the world of IoT and about testing. And I hope it will be separated into three parts. So just for the first one will be about IoT. So what IoT exactly is, uh, some examples how it really works. The second one will be about building the team, building the environment, architecture in IoT world. Most companies working in such area are small companies, and the same example is here. So I will try to show you how hard it is to introduce something like that. And the last part will be, the longest part will be about actually technical stuff. So some code, some architecture, and some tools to use. Okay. Uh, this is, I think, the better picture than the previous awful, and I love it from today. That's from this morning. So this is the only correction in my presentation. Uh, the first sentence, and I think the sentence will, this is the sentence we are following still, because 3 or 4 years ago, when we were starting, the IoT world was absolutely new. So it was not possible to Google somewhere or search the information and then copy paste it and trying to introduce into your own environment. So as Alan Kay said almost 50 years ago, so quite a lot of time, the best way to predict the future is to invite it. And that's how we are trying to introduce such approach. Okay, so maybe how many of you heard about IoT? Someone? Okay. Is someone of you working in IoT environment? One person, yeah. So I hope you will bring with you something worth, some value. So IoT in general is, if I would say it in one sentence, this is the network, but collecting, aggregating the real devices, not like the network we usually know. So the devices are gathering data, then processing, and then sending it, and sometimes make some decisions. It could be sensors, it could be some hardware. For example, if you are outside your home and you want to be sure your cat is always fed, you can use IoT device, like the machine always give your cat some portion of food. Okay, about IoT and some predictions. Gartner, one of the biggest portals, is predicting that it's from 2015, yeah, for 2016. There were 6.4 billion connected things, and the same source, I mean Gartner, is predicting that till 2020, I suppose, there will be 25 billion devices. And when I was creating this presentation, the IoT was the, let's say, second sexiest technology of the year. But I've checked it yesterday, and the same source, Gartner and also Reuters, is predicting that IoT will be higher than, for example, virtual reality or artificial intelligence or machine learning. So I think this is area for us as the testers to somehow put our work. So now, what about the products? IoT can work in a lot of protocols. So the most known, I suppose, are Wi-Fi, NFC, and Bluetooth. There are also a lot of others, but those three are the most common. Actually, we are working with Bluetooth 4.0, and as you can see, this chip is really small. All the intelligence, all the electronics is inside such chip, so you can create really small devices. But as you can see, it could be much larger. So the area, the spectrum of products could be really huge. So here, just to not get into details, you have a lot of examples, but the company is actually working with this one segment. Okay, it's not visible here. So it's lighting, like bulbs, like the switches, so dimming, changing color on and off. And on that example, I will be showing you the technical part and adding some components. But of course, even if you have some devices, you still need to something to control it and to configure it, because just steering it or controlling is not IoT. It is not processing data, gathering, and then sending somewhere, for example, to cloud, and make decision on it. So I think the most comfortable is working with mobile devices, but it could be any other, like web browser or something else. Now, here you can see the iceberg. About the iceberg, there is just a few percent of the ice visible for the viewer, for the watcher, and in this example, it will be our end user. So for him or for her, this is just some functionalities. So operating on the bulb, set a bit, making association, updating firmware, or sending into cloud. But there is much more below. So firstly, we have hardware. So if you want to produce, if you want to develop the whole IoT device, you have to think about hardware, because, and that's the biggest rule, the biggest challenge, that IoT is also hardware. And the second, on the right, you can see that this is also firmware. You can consider it as a middleware, something between hardware and software. So all the intelligence that the device have to contain inside to process it, make decision, and then doing something. So that was the first part about IoT. That was really short because unfortunately we do not have time. But how to create the team able to test such things if you have those three aspects: firmware, hardware, and software. So, like in most companies, there was only chaos and nothing else. Just some example what was wrong, but I think that there was everything wrong. The first point, everything developed was to deliver something on trade fairs, on events, on presentations, not creating just the real value of the product and sending to the client, but for the specific purpose. So not developing the product. Then requirements, because of the new technology, the requirements were changing very often, even on the daily basis, a few times per day. So if the architecture was not considerably, it was not able to maintain it, and what's even worse, to develop the new components to the test environment. Then, unfortunately, even those component tests were not prepared. Not saying about the test for the system, end-to-end testing, because still changing requirements, and that's closed circle. If you don't have time for the developing, you don't have time for testing, and it's hard to get out of that circle. Then no analysis of product and project risk, no TDD. There was no component testing, but either no TDD, no framework, no methodology, and no unit test. So the lowest part of test pyramid. As we know, it should be the most important part, but in that case, that was part that the effort was not put at all. And everywhere, proof of concept. So everything was not the product, but just a mock, like you can treat it. No documentation, and no enough tester. So we decided to create the team responsible for the test systems. And the team consists only testers. So probably most of you can say that this was not the Scrum team, but later I can argue with that because we are covering all the areas. So automation testing, manual testing, security, and some technical stuff for the real engineer, like drilling or soldering or connecting, just mechanical stuff. And the main responsibilities was to build and maintain test environment in fully automated way, and parallelly just helping other teams in their activities. Okay, so simply we can start the technical part. Okay, let's imagine the simplest scenario. I couldn't. Okay, I can imagine, but there is probably not a lot of simplest scenario. Like you have the bulbs, like here, and you want to turn it on from the application, which actually I don't have, so sorry, and turn it off using switch. Of course, there are more functionalities, but imagine the simplest scenario. Turn on from the application and turn off using switch. I can give it to you. It is one way to destroy all the environment. Just have fun. If someone succeeds, I can congratulate you very much and somehow find a gift. So just try. Okay, so looks really simple, because what could be hard to turn on and off the bulb? And the scenario looks like that. We want to use application, and everyone I think know how it's working. We are using Appium. Flashing, I mean, always be up to date with the current firmware. So like software, but we have to update the real device. And then the real test flow. So configure network, change state once, and then change state the second time, this time using switch. Okay, so looks really simple, yeah? In reality, it's not quite simple. So the challenge is we discovered doing some risk analysis very fast. How to flash the device to be always up to date. Because software is easy. For me, it's easy as a guy working with software before to update. But what about hardware? How to update firmware to be always up to date? Then how to control it? Because we can, I don't know, for example, employ someone. The best person I think is student to click it, but we want to do it in automatic way always. And then how to verify if the bulb was really turned on or turned off. And again, we do not want to do it in the manual way. And finally, if we have so many sources, multiple sources, how to aggregate data and make some decision based on that signals. Okay, and here we have some areas in we identify that it will be necessary to put some work. And here's a lot of areas. For example, we have just one single component, mobile application. I'm not saying about testing, but about using, like turning a bulb or changing the state. So after such analysis, that was not so simple, such simple as we are thinking, because even adding some components, some single components, was a huge work, and the requirement was to deliver it as soon as possible. So, as the Scrum says in the guidebook, let's make it step by step and increment every time. So, if we want to use, for example, sources from other teams, like the team responsible for developing and testing mobile application, we have to follow the common methodology and then not write our own version of library to test application, but to use already made. So do not do twice the same job. Second, And that's what exactly Scrum Master should do. It's facilitating external processes. Third, automation tool freedom. I mean, not exactly give the full freedom, but let them choose the best way. Consider architecture, of course. Uh, and my favorite, brainstorming session. I personally had some experience. It's very hard to put some ideas like that on at the big companies or corporations, because from the company point of view, then it has no value. But as I discovered, when you are putting all the testers in the single room or somewhere together, they can put some knowledge and find their own solutions, like I will try to show later. And the last, give them autonomy. Just do not be like big brother, stay at them, but let them work on their own. Okay, what was the requirement? So firstly, dirty cheap. Uh, as a startup, as a small company, it's important because, for example, to control switch, the best way should be just buy manipulator, but it's terribly expensive. So the idea was to just uh, unleash the creativity of people and let them find a solution. Then simplicity. So something like the developers well known, write the code that someone else can use. Modularity. So do not. I can identify the product, the web product, based on microservices. So every component is separately added, not build the monolith because of so many components. Then scalability and, of course, reliability. Okay, so we can move on to my favorite, of course, as a technical guy, move to the technical part, how it looks and how we can deal with such challenges mentioned before. So let's start prototype. And very important here is a yellow rubber duck. All the developers probably agree with me. There is no way to develop without yellow rubber duck. But the journey started with Lego. While the team was completing, all the guys working with web applications had no idea how to deal with hardware stuff. So we gave them the task to check, and that was really important for the company at the time, to check if the plug connected to the electronical socket is behaving as it should. For example, if we have value in the range between 3 and 4 amperes, it should change the light to green. And if the value is about 10 amperes, it should report an error. And with it, Lego, it was working, but it was really painful because everything was disconnecting, everything was burning because of the high values, but it was somehow working. And for me, that was good lesson learned. But let's move to the challenges. And the first one, how to update firmware on the device to always be up to date. We used the embedded platform. Here is Raspberry Pi to gather the firmware from cloud before it was built, and very often software sent to cloud, then downloaded and programmed by the debugger. And here is one very important lesson, because some devices, some hardware is working under high voltage, like 230 volts. And if you connect it directly from the embedded platform to the device, there is really high probability that it will burn. Of course, everyone likes flames and fire, but it can cost a lot of, and the most spectacular, I suppose, was to burn notebook, the device and the debugger at once. And it was done by student, but anyway, we get some lesson. Okay, and the second challenge, how to control switch. It could here it could see quite hard, but from my point of view, it's quite simple. I've tried to build it somehow with no knowledge about electronics, but it was just sending the output on a pin like 0 or binary 0 or 1, and then the switch was on or off. And how it looks like from the in the code, then it's really simple. Just implement the class and configure the proper channel, like the pin number, to the channel on the switch. And then you can easily create some methods like on bulb, turn on the channel, turn off. You can hold the channel to increase the lightness or change color. Or you can, I don't know, for example, wake up the device, because I didn't mention IoT devices very often should be built to be low consumptional, consumption low power, because if you want the such switch work 5 or 10 years, the device should be sleeping, and then if we want to steer, it should be only then wake up. So if we want to wake up, there is some sequence to push 2 buttons, and then it should be wake up. Or you can do factory reset, so remove all the dependencies between devices. And this is how we can destroy such environment. So you can still try if you want, but write the code in such way allows us later to use just some methods, just single one line of code to build the test flow. Okay, and then we want to verify if the bulb was turned on or turned off. And for me, the only solution was to build the vision system, always watching the matrix with bulbs and notifying if something were changed. And here is how it looked. So we used one of our developers to make such environment, to make the matrix. Here is, I suppose, 9 bulbs. And this is one of the requirements, so dirty chip. And here it's exactly dirty, but it's also stable, and yeah, the costs are really low. But of course, that's not such simple. Some lessons learned from this task. Unfortunately, if you want to gather the image from the camera, the influence from outside is huge. For example, you can have a higher light from outside or lower, and you have to separate somehow. But even if you do that, that's not enough, because 2 bulbs can interference between each other, and if they interferencing, the value is totally different. So here you have HUD to put on the matrix, and here how it looks like from the camera, and you are receiving just 9 values, and then you can continue your test flow. Okay, so this is how I was expecting to look like. Just trigger signal, gather value, and then you can continue your test flow. In reality, it looks like this. To not get into some details, it could be some separated presentation about the vision processing or using vision systems in testing. But there is a lot of processing image, then creating some areas to get some parameters, and after that you can send the output to the test flow. And just one example, here is just a single value changed, and the values are totally different because of only one value change. And there are many, many more, usually like 7 or 8. Okay, and the whole environment looks like this. I didn't mention about mobile application because it's the most known, I think. And yeah, here is Appium and iOS and Android. So we have 4 sources of data to make decision. One from mobile application, one from one from vision systems. So we have real behavior. One from the real devices, like switch or bulb, and one from our embedded platform, so firmware and cloud. Yeah, and how to then think how to write the test cases if we do not know all the components, and the components are like 4 or 5. And I encourage you always, if you have such case, to gather the testers and give them the possibility to make a brainstorming, and then you can have all the board written with some ideas and test cases. And just here are 3 pages of class implementation. So all the parameters were a class implementation, like the addresses to the devices, which we can then flash, the channels, the number of bulbs, the MAC addresses. So all the information we need to then continue our process. Yeah, so that's quite huge. Usually, as you probably expected, it's much less information. But while doing such thing, we can then create the test case like this. So making association between the devices is like the one line of code. So click device on a list in mobile application is just a single line of code. And as a parameter, you can just give a MAC address of the bulb. Then you can use our library for switch, and the method is like switch wake up. Then the same with bulb, and gathering information from vision system is just receiving binary values, 1, 0 if that was turned on or turned off. And those 3 cases are 3 others from our test flow. The first one is provisioning, and provisioning is adding the device to our network. So network of IoT devices. And we are doing the same factory reset, so removing all the data, then wake up the device from application and check if it's on application. The second example is quite similar. So we are, I don't know why we are resetting Bluetooth, so don't look at this, but we are waking up the switch, then add device, checking if it's on the list, and then factory reset of switch. And the last one is sharing our database of the devices to some services like Gmail or Google Drive. And in short way, it looks like this. So test arbiter is gathering all the data from the components like microservices, then sending to environment. The environment is taking decision if the test was wrong or not, and then if it's possible to fully automate, the test results are sending to any platform, to any service. For our project management, here it's just Jira, and this is not a problem to send it to other services. And yeah, here is just Darth Vader, because it looks nice on the presentation. So let's move further. This is the board, and I encourage you to do the same at your company if it's possible, to put some dashboard while entering the company, because if something went wrong, for example during nightly builds, the product owners has no choice to just leave it and move some other activities. In such case, everyone can see it, something went wrong, the product owner has no choice. Uh, he or she has to make some activities and check what was wrong. And it is not your deal what was wrong, you are just reporting it. Okay, but to be honest, it is not such simple as it was on the previous slides. Just a few problems met during working with hardware. The first one was the long SSH connection. It was like 4 seconds, I suppose. And if we are changing state like, I don't know, 10 times during one test case, it's 40 seconds. And if you have some, I don't know, like 20, 200 or 300 test cases, you have no time even if you are doing tests during the night because there is not enough range of time. So you can just run it during the weekends. Then PWM high frequency. So it's more from hardware, while testing protocol is called UART. Then electric discharge, and that is very important because probably most of you were kicked somewhere by the electric, even while touching another person. But working with device, usually it reset the device, so the test and the rest of the test makes no sense because it was resetted. But in some cases, it was even broken. So, for example, I don't know, the flash could be totally erased. Then busy camera buffer, so process still working somewhere in the background. And while flashing, so using the cloud to download the firmware, we were receiving a lot of timeouts. And we didn't know why, but that was a problem to start even the first test. And the last one, I think the most known for you, some language versions, different screen size, or different platforms. But as I said, we were some kind of Scrum team, so we were covering most of the areas of the knowledge that we should to build such environment. And a long time SSH connection, someone has idea how to solve it? Okay, so I have idea. This authorization by certification, and from 4 seconds we decreased it to half a second. The next point was just to turn off the default values of IO stream and disable it, and increase more than 10 times. The third is my favorite and the most important for the whole test process. Maybe someone of you have, it's more rather like the common knowledge how we can deal with it. Okay, so we just bought humidifier in the shape of frog because humidity was too low to avoid some such situation. And the only thing we have to do now is just add some water to the humidifier and everything is done. The simplest, the cheapest. The next one was busy camera buffer. In such situation, we can just monitor process and turn off process if it's working. Turn off, maybe not really turn off, just kill it. Find the process, find the number of the process, and kill it. Then, because timeouts were caused by after flashing, the device have to wake up, and usually it takes less than 100 of milliseconds, but that's enough to break the test. So it's something like the page is not open, but we can verify if all elements were loaded. Here we don't have an opportunity to check if the device woke up. And then different screen sizes and different version platforms. So the most common, just gather all the information and determine it while class implementation. Okay. I suppose all the technical stuff was quite hard, so to give you some takeaways from this presentation, I have some points to present. So does Scrum really works? No, not always, but in our case, it was working. So I suggest, for example, now the company is working, let's say in Scrum, but it's pseudo Scrum. Four teams are working in Scrum, two in Kanban. But most of them, if there were a problem, just try to introduce Scrum, and then, ta-da, it was working, usually. Uh, then it's about the product. So always think about the product as a whole. So do not focus only on your own business, like you are creating the component, but think about it as a product you want to sell to the market. Because if the company is earning money, there's a huge probability you will get money too. But by the way, act small. So always add some stuff and then increment. If something went wrong, just reiterate it and try different option. And this is what I said. Always try to redefine and iterate it. This is mostly like Scrum said, but this is usually because of hardware. And hardware can give us a huge kick in the ass. And try to use the team creativity, because if you have people, do not treat them as just testers to check if the product is okay, but give them the opportunity. Even you can force them to give the idea. If the idea is wrong, it doesn't matter. Like a lot of American companies are thinking, if you were wrong, it is nice because you have some lessons learned. But always remember, do not make the same mistake again. Focus on interoperability, because we have a lot of devices, a lot of mobile platforms, and different version of operation systems. So if you do not want to build it again from the very beginning, just try to implement it. You could be easily easy to move to another platform. And yeah, modularity. So we cannot say we are building microservices because this is not a website, but we can still identify as a microservices, but in IoT world. And try to focus on risky functionalities. In IoT, the very, very risky functionality is updating the firmware. Because for the client, the only way is to do it over the air. So using your mobile platform, and you have your mobile, you have device, and it is doing over the air. It took usually a few minutes. If something went wrong, like, I don't know, someone is calling you and it is not working then, and the customer have to send you the device to refresh it, that's not a good marketing for your company. So do not leave the risk analysis always to the managers, to the product owners, but try to do it on your own. And yeah, that is what I do not like personally, that you cannot avoid physics. And the school knowledge is sometimes useful. I have to learn from the very beginning, but now if you are working with hardware, it's much easier. And remember, you are not a hardware developer. You are not prototyping all the mocks. You are just working with it. And I suppose a lot of people here, earlier or maybe later, will work with some hardware. So try to always think about all the issues that we are dependent from the physics. And this is it. IoT is also hardware, and we cannot avoid it, because this is network, but the network connected with devices. And the last point, and this is the most important point, and I didn't say anything about it, security. I think a lot of you heard about some funny stories, like people were hacking for example, cars, and then steer it, and then like somewhere crash the cars, or open the fridge, or destroy some. There were, as I remember, some Barbie, and just speaking and doing like the evil voice for the children because of hacking it. So security for me is the most important, but unfortunately, this is so huge issue that it should be covered by different presentation, and today we have no time. So you can Google it. And yeah, you can find something about protocol here, but from my side, that's everything. So thank you very much.